Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 4-8 homework solutions on analyzing graphs of polynomial functions. For this first problem, we're trying to graph this function that's in intercept form. So let's start by finding the zeros. Those are some easy points. If we zero out each of these factors, we end up with x equals 2 and -1. And next, let's take a look at the end behavior. So we have an x squared times an x and a positive out in front. So this is a positive x to an odd power. So that means that we have an upline sort of end behavior. And then one other piece of information, we've got two zeros here, so let's find a point in between those. I think 0 is a pretty easy number to plug in. So if I just plug 0 in for all the x's, that's going to be -2 squared, which is 4, times 1, so 4 when the dust settles there. So let me put all this on a graph now. We have -1 for the first x-intercept, then we had 0, 4, that's the point we just found, and then we have 2, 0 over here. Now our end behavior says that we're starting low and ending high. So we're going to start below the x-axis, go through this point, then come back down, and for ending we're going to have to bounce here to be ending high. So that's the way this one's going to work out. To graph this function, let me first find some x-intercepts. So zeroing out each of these factors, we've got x equals -1, +1, and then 3 minus 3 also zeros that out. For our end behavior, we have a positive. This is going to be an x squared times an x times an x. So that's a grand total of x to the 4th. So we have a positive x to the 4th, positive x to an even power for our lead term, basically. This is an up parabola sort of situation. And we also want to figure out a few points in between these zeros. So a point between -1 and 1, I bet if I plug 0 in, that'll be pretty easy. So that would give me 1 squared times -1 times -3. That would be a grand total of 3. And then a point between 1 and 3, if I plug in 2, that should do that one. So we've got 2 plus 1 is 3, squared is 9. And then this is going to be, let's see, 2 minus 1 is 1, 2 minus 3 is -1. So this is going to be -9 when the dust settles. Let's go ahead and graph it now. So we have our x-intercept of -1, that's our first point. Then we had 0, 3. We have an x-intercept of 1. 2, -9 will be down here. And then we have 3, 0 right there. Now we're starting above the x-axis and ending above the x-axis according to our end behavior here. So starting up here, we're going to have to bounce to go through that point, and then we're going to have to go through this x-intercept to get to this point, and then coming up here and ending above the x-axis. On this problem, they want us to analyze the h of x function using some technology. So let's go to Desmos and graph this one out. So here I am on Desmos. Let's do h of x equals x to the 4th minus 3x squared plus x. And let's move this up so I can see it. Now in terms of turnarounds, since this is x to the 4th, I'm expecting at most 3 turnarounds. And I only see, let's see, we got 1, 2, 3 actually. So all 3 are accounted for. And we're also expecting at most 4 x-intercepts since this is x to the 4th. Let me zoom in and let me zoom out first and make sure there's nothing hiding anywhere. Nope. So let me zoom in now and see how many x-intercepts we actually have, because it's kind of hard to tell. We've got 1 here. We've got another one closer in at the origin, and another one here, and another here. So that's 4. That accounts for all of those. And then we also have our turnarounds. We've got 1 down here, 1 right there, and 1 over there. So I'm going to cut and paste all of this stuff with all of these things kind of locked into place. So here is a graph of everything. This is a little bit tricky to read because there's a lot going on with this one, but let's give it a shot. So for x-intercepts, rounding to 2 decimal places, going from left to right, we've got -1.88. Next up, we have the origin, 0, 0. And we also have, let's see, a little bit further along, we have let's see, this one right here, 0.35 is this x-intercept. This 0.17 here is referring to the max. We'll get there in a sec. And then finally, here over here at the end at 1.53, that is our fourth x-intercept. Now for local maxes, here's our local max, 0.17, 0.08. For local mins, there's two of them. One of them's at negative 1.30, comma, negative 3.51. And we have another local min over here at 1.13, comma, negative 1.07. For the increasing intervals, we're increasing in a few spots. We're increasing from negative 1.30 until we get to this 0.17. So that's one increasing interval. And also we're increasing for all x values greater than 1.13. For the decreasing, it's all the other places. So x less than negative 1.30, this interval here. And also we're decreasing on this little stretch between 0.17 and 0.113. And I think that covers everything. For this problem, to see if this is even or odd, we can do a quick check with the exponents first. Since we have a mix of even and odd exponents, 2 and 1 and 0 there, this indicates that we're going to be failing both the even and odd tests, but we're going to show them anyway just to really rigorously prove this. So for the even test, let's plug in negative x for x and see if g of x and g of negative x are the same thing. So g of negative x, that's giving us positive x squared, which matches what we started with, and now negative 5x is different, and that plus 1 is still there. So g of x does not equal negative g of x. This proves that this is not an even function. To prove whether or not it's an odd function, we have to do negative g of x, which basically means we negate everything in the g of x function, and then we'll compare that to g of negative x. So we've got negative x squared minus 5x minus 1. This does not match g of negative x that we calculated earlier. This proves that this is also not an odd function, so then this is neither. On this problem, to figure out if this is an even or odd function, let's first do the quick sort of cheat and look at the exponents. 6 and 2 are all even, so that indicates that this is going to be an even one, but let's prove it with the even test. So we'll plug in negative x for g and see if that matches what we get when we do that matches what we started with. So g of negative x, this is going to be negative 2 positive x to the sixths. And then this is going to be a plus x squared. And that does match g of x right here. So because those two things match, this proves that we do have an even function. For this problem, checking even and oddness, it looks like we have 3 and 1 for our exponents. So we expect that this is going to test positive for oddness, but let's just do all our tests to be sure. So first off, we're going to calculate f of negative x, and while we're doing that, we can check to see if it's even or not. So f of negative x, that's negative x cubed minus 7 times negative x. That becomes a negative x cubed in front, and then this becomes a positive 7x. Since f of negative x here and f of x don't match, this proves, which we kind of already knew, that this is not an even function. Now let's do negative f of x and see if that matches up with what we already got for f of negative x. So negative f of x, we're essentially negating everything. That gives us negative x cubed plus 7x. And that does indeed match f of negative x. Since those two things are the same, that proves beyond a shadow of a doubt that this is an odd function. For this problem, we're told that the number v in millions of viewers of a weekly TV show can be modeled by this v function below. And x is the number of weeks since the premiere. And this is apparently only going to be going for 7 weeks. We're going from 0 to 7, where this function is still accurate. They want us to use technology or Desmos to graph this thing, and then they want to know when the number of viewers is at a maximum and how many viewers there are at that time. So let's go to Desmos and graph this out. So I'm going to make this the v of x function, and we've got 0.042 x to the third minus 0.5 45x squared plus 1.3x plus 5. And let's just move this up a little bit so that we can see everything. Okay, so let me zoom out a little bit. Let me just click the home screen. There we go. Now I can see things a little bit better. Now in terms of turnarounds, since this is x to the third power, we know that there's at most one less than that, so 2 turnarounds that are going to be on this graph. So these 2 turnarounds that we see here, these are the only ones we need to worry about. We know it can't turn around anywhere else based off of that. So let me just click on the one that's a maximum right here, and then let me just cut and paste all that onto my other screen. There we go. So we can just look at it here. So it looks like we're hitting a maximum for this function about 2 weeks in if we wanted to estimate it. And then the y value there, 6.1, that's saying that we have about 6.1 million viewers at that time. And that's going to be, let's say viewers, not users. There we go, viewers. I mean, it's a TV show, not a game, right?